Hi everyone, this is Tim at Maker's Machining here today. We're standing by our tool post grinder and we're going to talk about how to sharpen a drill bit. Typically when you buy a drill bit, it's already sharpened nicely for you. You've got the correct angles on it, the correct relief behind the cutting edges. But as you use it, and depending on what you're drilling, you're going to have to sharpen it occasionally. You don't want to throw it out just because it got dull. You can sharpen it. So we're going to talk about how to sharpen that drill today. The one thing that you want to look at on a drill bit is, typically these things go into a hole like this, but it's easier for me to explain when it's upside down from the way it's actually used, what we're looking at with the drill. So I've got this thing up here, and right here would be the cutting edge on the drill. I don't know if you can, how well you can see it here. Here's your cutting edge here. Behind that cutting edge, everything there has to be relieved away, so the back side of the drill, or the back side of the cutting edge, doesn't rub in the hole, because it won't drill, because the cutting edge has to be the leading edge going down into the hole as the drill's turning, and the back side has to be cleared so it doesn't rub. But you can't clear it too much, because if you put too great of an angle on here, the cutting edge up there doesn't have anything there to help support it or dissipate heat from when you're drilling. So you want to try to get as little of an angle on there as you can, but still have, clearance enough for you to drill that hole. The typical drill that you get, general purpose drill, is going to have a 118-degree angle between the 2 points. So if you go from 0 up, 118 degrees is your standard drilling angle points. If you're drilling and working with alloy materials, then you use a greater angle. So instead of 118 degrees, you make it a flatter point and go to 132 degrees. That helps give the drill a little bit more mass there to dissipate the heat. But you may also end up with a flatter hole in the bottom, which probably helps the drill maybe a little bit oversized, so you can maintain and not wear out the outside diameter of your drill. That's called the land out there. That dictates the diameter of your hole. If the drill is drilling perfectly round holes at the size you've got it sharpened for, once that land wears out, and down by the cutting edge it wears out more than the rest of the drill, you may never use it back here, but those drills taper down after a while, and then they kind of have a hard time drilling. It might seize up in the hole the deeper you go. But anyhow, you need to have relief by each cutting edge. You want to try to grind it, sharpen it centered, so each cutting flute is the same length, because if you're off center one way or the other, the only thing that's going to do is make your whole drill bigger. In some cases, whatever you're drilling, mild steel, you want to keep it centered. Alloy steel, it might by nature drill a little bit bigger, but if it's off center, it's going to go oversized. And if you're drilling copper, that's probably going to help you a little bit, because copper gets hot fast and it'll seize up on your drill. So if your drill is just sharpened a hair off center, the hole gets drilled a little bit bigger and it won't grab the side of your drill. I worked at a place where we did a lot of copper drilling, and that was always a problem. The drill would wear out because copper is very abrasive. The OD, or the land of the drill, would wear out, and we'd have to try to get that to go a little bit oversized so we could have a good life on the drill sharpening. Any other cutting tool, like a counter bore we've got here, you can kind of see that if this is square with the cutting axes, we've got this thing here sharpened on an angle. All 4 flutes are the same way. You might be able to see that angle that's on there, that relief angle. Here's a core drill. It doesn't have a center part that drills a hole. It's used for drilling holes and castings that might have a whole cord in them, and this will just go through and size it. That's why it's called a core drill. We've also talked about reamers some time back. Each little flute there has that same relief angle on it, so the leading edge that's doing the cutting is your cutting edge there, and everything else has to be relieved. You see me waving around here with this little drill sharpening gauge here. You use that to go up and check your angle, and you flip the drill, and you want both angles to come out the same. It's got a little scale on there so you can see, okay, am I within a 32nd or a 64th of being centered? You really want it perfect, so the only way you'll find out if it got sharpened perfectly is if you have two chips coming out of the hole as you're drilling it. Then you know you've got both flutes exactly the same length. I'm going to set this camera down here right now and get you a little bit closer up view of what I do when I sharpen a drill bit, so you know how to maybe get the thing set and do it safely. That's the main thing here with these grinders. You got a grinding wheel that's flying around a mile a minute, and you need to be safe. Now what I do here, let's visualize you've got a round wheel, whatever diameter is. This thing probably started out with a 10-inch wheel. It's worn down a little bit now, but you got this round wheel, and there's a tool rest on here. The grinder's not running right now, so I'm kind of showing you with my finger here. The tool rest is about where the center line of the wheel is, okay? Now, we're talking about sharpening the drill and putting a relief on it. So two things are going to get accomplished here at the same time. I put my middle finger up against the front of the tool rest, and my index finger is what I lay the drill on, okay? My left hand, I use that to arrange the angle that I'm sharpening at, and I also use that to help sharpen the drill up and down. Now, when I sharpen the drill, I want to bring this thing down till it's horizontal as best as I can gauge. And since it's going to be this much above the center of the wheel, it's going to automatically get some relief ground in the backside of the cutting edge. But I also still do a little bit of movement with the drill to get more relief, to make sure I've got relief. So I set it down there, I get it up against the grinding wheel. Usually if you're grinding something, you've already got an angle on your drill that you're just sharpening and duplicating. So that gives you something to kind of gauge by. I usually push it up against there, make sure I've got it, when the wheel's turning, got it flat, and I can see sparks maybe coming off of the flutes of the drill. I know where I'm at. I can kind of tell if I'm flat on there. The face of the wheel is nice and flat, so I want to get my wheel up against there. Now I'm gonna grind and sharpen the one side like this, and then I'm gonna index it around and do it exactly the same on the other side. Well, you say to me, how on earth can you get that angle to come out the same place as you had it on the other side? You know, you're just turning it around. You don't have an accurate indexer. Well, as I'm holding this drill and doing my grinding and sharpening, I've got it in there. As I hold it, my finger gets a little line in it from holding the drill bit, you know, against the flute, right like that. And what I do, I use that to, as I get up there, I'm sharpening here. I rotate this thing around. I can feel when I'm in the same place on my finger on the opposite side. So that's how I go about doing it. All right, I'm going to put my safety glasses on here. Before I turn this thing on, I've got a pot of water here, because if you're sharpening the drill, you don't want to get it too hot, because if it gets too hot, and especially if it starts turning blue, you're losing the hardness in your cutting edge. So you need to make sure that the hardness stays intact, and so quenching it quickly to get that temperature cooled back off is an important thing to do. The grinder has a light on it, and it's got a glass guard on it. I've got my safety glasses. I'm putting them on right now. You have to be careful, because safety glasses, I got something in my eye one time when I was sharpening something, and I had my glasses on, and a piece of grit came off and must have bounced up and got underneath there, and I had to go get something removed from my eye. That was not a pleasant experience. Okay, I'm going to turn this grinder on here, and like I said, I'll talk a little louder here. I got my middle finger up against the tool post. I got my index finger, I'm not even within a ½ inch of that grinding wheel, so I want to keep it that way. I will use my thumb to push it in and out, and my left hand also. So that's how I get the pressure on the grinding, the drill against the grinding wheel. You got to push against it somewhat, or pressure on it, otherwise you won't grind it. Now you can see when I get to the horizontal position, I want to see sparks coming across the tops of the flutes, and then I push it and turn it so there's relief ground behind that thing. You can see what's happening. When I come back down to horizontal position, I can see sparks coming over the top of that. So that's your point to know that, okay, I'm sharpening at cutting edge, I rotate it around. I'm going to index it, I put it right in the same groove in my finger. Everything stays the same, I hope. I come around, do the same exact thing to the other one. Bring it down. When I get it horizontal, you can see the chips or the sparks coming over the flute, and you know you've got it. And then I go right back up. And you can see there's a nice sweeping radius on there. I got a little spot in the corner I didn't quite get. Here's another nice, smooth, continuous surface. I can go back there and do both of them the same again. Put it in here. I'm going to cool it off. Didn't get very hot because I didn't have to take too much off there. If you get to where, I'm going to turn this thing off here. If you get to where you have to sharpen a drill that's broken, then maybe you have to take a little bit more of a grind on it and put some pressure on it so it cuts away that metal that's damaged. Then it gets hot pretty easy, so you've got to be a little careful with that. Okay, looking at that drill bit, I don't know if you can see the very tip of it there. Here's my cutting edge here and up here. When those things are in line with each other, your web has to be tilted to the right, and then you'll know you've got clearance in there. If it's straight up and down, it's iffy. It may not be cleared enough on each side. But if you can see the angle tilted to the right, then you know you've got clearance on there. This looks like a pretty good sharpening job. Some people have, some of those drill sharpeners. They do a nice job, but if you don't have that, and you've got a bench grinder or a tool post grinder, you'll be able to manually sharpen your own drills. Again, I caution you to make sure you have your guards on, have your glasses on, use your middle finger against the tool rest, your index finger under the drill. That way you're not even close to the grinding wheel, because grinding wheels don't cut you, they will remove matter. So it would take a long time to get healed from that. So anyhow, you've got a nice sharp drill. The best way to check if you did a good job is to drill a hole, and if you got chips coming out, both flutes, you've done good. So anyhow, we'll sign off here. That's a real brief explanation of sharpening drills. It takes practice, so just be patient. Try it out, drill a hole, try it out, drill a hole. It takes a while to do it. If you do it all day long, it's a piece of cake after a while, like a few other things in this trade. So anyhow, we'll talk again with you soon. Thanks for listening.